Okay, so for this next problem, it says we need a equation of a line that is perpendicular to x equals 4 and passes through this point 3, 8. So because x equals 4, this looks like the last two problems, very similar to it, but because x equals 4 is a special case, a Hoyvuk's case, this is actually super easy. It's probably one of the easiest ones on the exam. So if we think about our Hoyvuk's, x equals 4 is definitely a Vux problem. So this is a vertical line. So if x equals 4 is a vertical line, what is perpendicular to a vertical line? Well, a horizontal line is a perpendicular. Well, how am I going to get a horizontal line? Well, the equation of a horizontal line using our Hoy tells us that it's going to be a y equals, so I have y equals some number. And that's my answer, y equals some number. Well, how am I going to get that number from? Well, I'm going to use the point, x1, y1. Well, which point do you think I should use? Should I use the x point or should I use the y point? Well, in this case, because it's y equals, we're going to use the y point, and that's as simple as it is. Okay, very simple. You don't even need to write all that work. You can probably just do it without it. In fact, let me give you a couple of extra practice problems right here just so you can practice them real quick. So go ahead and pause the video and write these next couple down. Okay, so I just came up with 3 new problems, problem 5b, problem 5c, and problem 5d. Things you need to know is the 2 lines that are look like they're parallel means the word parallel, and then these 2 lines that kind of look like an upside down T, that means perpendicular. So problem 5b says find an equation that's parallel to x equals 5. Now x equals is a Vux, so that's a vertical line. So what's parallel to a vertical? Well, another vertical. How do we write vertical lines? Vux says we write them x equals, and then you pick off the x number 2 from the point. All right, the next problem, y equals -3. Well, that's a Hoy problem, which is horizontal. Now, I need an equation that's perpendicular to y equals 3. So perpendicular would actually be a vertical. So how do I write a vertical line? X equals, and then you look at the 2 values, and I pick off the x value off the point. X equals 7. The next one we have parallel to y equals 4. Well, y equals is a Hoy, which is a horizontal. And what's parallel to a horizontal? Well, another horizontal. So in this case, it's a Hoy, so it's a y equals, and I go ahead and pick the y value, which in this case is 5. So there's 4 examples for you. You only have one on the test, but I just gave you a couple. One thing to notice is that if it's parallel, notice what happened to the letter. The letter was x and the letter stayed x. If the letter was y, the letter stayed y. If it's parallel, the letter x or y stays the same. Kind of like when we have parallel lines, the slope stays the same. So in this case, the letter stays the same. But if we have a perpendicular problem, what happens to the letter? Well, the letter switches. It goes from y to x. Over here we had a perpendicular, which switched from x to y in our answer. So that's just something a little bit interesting to notice. Okay, on these next problems, we're trying to use our transformations of basic functions to sketch the graph of each function below. Make sure the graph you sketch passes through the key points. So there's a few things that I'm going to need to know. I need to know the basic shape, horizontal shift and vertical shift, the vertex, and then the compress and stretch. So the basic shape of a cubic function is kind of like the elongated S shape on its side, not vertical. So the horizontal shift, that's inside with the x, and that's opposite of what you think, so that's -4. The vertical shift is outside of the function, which in this case is -5. Put those 2 values together and you get the vertex. The vertical stretch and compress, remember this is a vertical stretch and compress, is the number out in front, which in this case is 1. Which means when I go back to look at my basic shape, to get the key points, normally go right one and up one, and left one and up one. And because my compress and stretch is 1, that means I'm not going to change how I'm moving left, right 1, and up 1 or down 1. So now I'm going to start at my vertex, which is -4, -5. Then I'm just going to go from my vertex, right 1 and up 1, left 1 and down 1. Now these 3 points, if you just had these 3 points and you didn't know what the basic shape was, you're never going to get this correct. You need to know what the basic shape looks like so that when I try to sketch it, I'm going to get the right shape. Because those 3 points could make a line, they could make all sorts of things. It can make a cubic. So make sure that you're doing it correctly with the correct shape. Now some of my students sometimes have a hard time with sketching this. So a cheating method to sketch this is if you want to turn your paper sideways and then just do like half a parabola like that from the vertex up, and then switch it around and then do another half a parabola there. Now technically it's not really a parabola, it's a cubic function which moves at a different rate than a quadratic function, but it's a little bit of a cheating method just so that you can sketch it right, because I've had students sketch all sorts of like crazy things and they're doing their best, but they're just not getting the right shape. So that's one way that might help you. Okay, the next problem, because there's a squared, that tells me it's a quadratic function. My horizontal shift is inside with the x, and that's opposite of what you think. So in this case, it's -5. Because it's +5, you do the opposite. The vertical shift is outside of the function, in this case -2. Put the horizontal and the vertical shift together and you get a vertex. I can go ahead and plot that already if I really wanted to. My compress and stretch is the number out in front, which in this case is 3. Okay, so normally on my basic shape, I would go right 1 and up 1 and left 1 and up 1 to get to my key points. But because I have a compress and stretch of 3, I am now not going to go right 1 and up 1, but I'm going to go right 1 and up 3. Okay, so take out that 1 and it's not going to go up 1. Now notice the left and right 1 stays the same. That's because this is not a horizontal stretch, it's a vertical stretch and compress. So the only thing that you're changing is the vertical components. So on my picture, from my vertex, I'm going right 1 and up 3. Left 1 and up 3. So I have a parabola there. Make sure that's a nice smooth curve and no sharp edges. On our next problem, because there's a cube here, that tells me it's a cubic, which looks like that kind of elongated N shape. The horizontal shift is inside with the x, and it's opposite of what you think. So in this case, because it's x -4, the horizontal shift is +4 or +4. My vertical shift is outside, which notice there's nothing really meaning added or subtracted outside. So because there's nothing, we can think of it as a plus or minus 0. Put those two values together, 4, 0, and you get your vertex. And I can go ahead and plot that if I really want. My compress and stretch, or stretch, is a vertical compress or stretch, don't forget that, and it's the number out in front, which in this case is a half. So, looking at my basic shape, normally I would go right 1 and up 1, left 1 and down 1 to get to the key values, the critical points. But because I have a compress and stretch, that's changing how I get my critical values. So instead of going up 1, I'm only going to go up a half. So instead of going down 1, I'm going to go down a half. So from my vertex of 4, 0, I'm going to go right 1 and up only a half. Left 1 and down only a half. And what happens is my cubic kind of gets a little wider than normal. Let me do that one more time. So normally it would look a little bit steeper like this, but because we only went up a half, it kind of widens out a bit. It's really not widening so much as it's being compressed towards the x-axis.